Okay, so here is Cycle K Phase 13. So we're going to learn something called the fundamental theorem of calculus. And, okay, so I'm going to show it to you in two ways. All right. Okay, and the notes are attached, so if you don't want to write this down. So the fundamental theorem of calculus says this. If you want to evaluate this definite integral, all right, and just like a derivative means the slope of a tangent line, a definite integral means the area under the curve. Okay, so if you want to evaluate a definite integral, which means find the area under the curve of this function on this interval, what the fundamental theorem of calculus says is that you can just do it like this. All right, so here I'm going to introduce some new notation. So this is going to be equal to, now let's do brackets like this. At the end of the brackets, you just take the endpoints of the interval and you put them there. And now inside of here, you go like this. All right, and I'll tell you what capital F is, where capital F of x is any antiderivative of the original input, okay? And when I said any antiderivative, remember when you're doing an antiderivative, there's a plus c at the end. So this could be, this is any member of that antiderivative family. So the c could be anything, all right? But then we're not done. That's just the middle step. And then what this is equal to, you plug in this endpoint, the top endpoint, and then minus, plug in the bottom endpoint. All right, now let me tell it to you a different way. So, so x equals a to b, okay, g prime of x dx. So you could think of the input of the integral as a derivative, like this is already the derivative of some function, and then this is equal to, okay, so the antiderivative of g prime is g. All right, and then I'll just say where g of x is, I'll say antiderivative with any c. And then you plug in b minus, you plug in a. Okay, so we're going to do some examples. Now, because what goes in here can be any antiderivative, so you could use any c, we choose c to be 0, because then we just, you know, there's less that we have to write down. So I'm actually going to do this second one first. I'm going to do 3 examples. I'm going to do this second one first. And, oh yeah, and I'm going to show you how to evaluate this, guys, with the calculator. So let me actually get the answer right now. Okay, so we want here the area under the curve from -2 to 1 of this function here. Now, I already showed you how to do it with the graph, like a definite integral on the graph. But another thing that you can do is math and then 9. Okay, math 9 is going to open up a definite integral in your home screen. Remember, math 8 is for derivatives. And then in here, x to the 4th. Okay, and then you put that at the end. Okay, so 8.85 is the area under the curve there. And let's use the fundamental theorem of calculus and see, you know, we should get the same answer. All right, so what the fundamental theorem of calculus says is that this is equal to, I'm going to open up some brackets. So the integral sign and the dx, they disappear. Okay, we just open up these, they turn into these brackets. All right, sometimes I put the x equals and then oftentimes they don't. It's just implied that these are x values if they don't put x equals. All right, now antiderivative, we could just use the power rule for everything. So the coefficient is 1, 1/5 x to the 5th plus 1/4 x to the 4th minus 4/3 x to the 3rd plus 6x plus c, but you could use any c, so we'll just use c is 0. We'll choose that member of the antiderivative family where c is 0. Okay, now I plug in 1. So this is 1/5 plus a 4th minus 4/3 plus 6 minus, all right, so that's what I get when I plug in 1, minus, when I plug in -2, I already did this, so let me just save us time, and you get -56/15. Plug that whole thing into your calculator, and you will get 8.85. Okay, which is the same as what we got at the beginning. Okay, so let's do the others. Okay, now the other ones, guys, so when you're taking the antiderivative of the input of an integral, you take the antiderivative of each term separately. And sometimes, like for one term, you'll want to pull out a coefficient, and for the other term, you won't need to pull out that coefficient. So it helps to, think off to the side of the antiderivative in separate parts. And if you don't need to do it that way, if you could just see it without doing it that way, that's wonderful. But I'm going to do, all right, so let me go like this. So this is going to be equal to x equals 1, 2, 3. Now what goes in here needs to be the antiderivative of this input of the integral, of the definite integral. So I'm going to do a little aside. All right, so down here, let me do an aside. So I'm going to do the antiderivative. So I'm going to do like an indefinite integral, just a regular integral, right? A regular integral, 1/4x dx. All right, and again, you don't have to do this. I'm just trying to really break it down for everybody. Okay, now without the numbers on the ends, it just means antiderivative. Okay, it doesn't mean area under the curve, it just means antiderivative. So I could take this 1/4 out, 1/x dx plus 2 dx. So this is a 4th. The antiderivative of 1/x is natural log of the absolute value of x, and it's going to be an open notes test, your AP test, so you can have that written down. But it's better to know it because you don't want to waste time, really, it's easy to remember. And then antiderivative of that is 2x plus c. All right. But c could be we could choose any c and put this in there. So I'll just choose c to be 0, and this is a 4th natural log absolute value of x plus 2x. Okay, then I plug in 3. This is a 4th natural log absolute value of 3 plus 6 minus, then I plug in 1, a 4th natural log absolute value of 1 plus 2. Just to point something out, I don't actually need the absolute values because 3 and 1 are positive anyway. So yeah, but I'll just leave it there instead. Guys, natural log of 1, that's 0. All right, and if you don't remember it, natural log of 1, that's 0. All right, so this actually ends up canceling there. That's 0. I'll go like this, that's 0. And so this is a 4th natural log absolute value of 3 plus x minus 2 equals to 4 plus 4. Okay, now let me check this. So math 9, right? Math 9. And I plug in this original from 1 to 3, 1/4x plus 2. okay, is that, let me see if it's the same as that. 1/4 natural log. I don't need the absolute values. You could use them, but I don't need them because 3 is already positive. Plus 4. Yep, it's the same. We did it. Okay, one more. So this is similar to the other one, where you want to think of the antiderivative like in 2 parts. All right, so it's going to be from x is 0 to pi. All right, so this is a little aside, and I'm doing the antiderivative of sine of x over 5 minus, and part of the reason, guys, I'm doing this so carefully is because your notation really needs to be perfect as can be on this test that you're going to take, because it's all for your response. Okay, and then I could take out the 3/5. Okay, now I need to know the antiderivative of sine. All right, so off to the side here, we have this thing, sine, cosine, negative sine, negative cosine. All right, so I've got sine, and I want its antiderivative, so I go the other way. So it's negative cosine. So this is negative, oh, shoot. This is negative 3/5 cosine of x minus, I bring down the 2, oh no, here's a kitty. I bring down the 2, the new exponent is 2, x to the second plus c. Okay, so that's the antiderivative family. That's what an integral means without numbers on the ends. A definite integral means the area under the curve. So we could use any c. I'll use c equals 0, and then this is negative 3/5 cosine of x minus x squared. Okay, I'm going to plug in pi. Negative 3/5 minus, I'm plugging in 0. Negative 3/5 cosine of 0. Oh yeah, minus 0. All right, now you could think of your unit circle. Think of the unit circle, and cosine is the x coordinate. All right, so the x coordinate over here at a rotation of pi is -1. X coordinate here is +1. So this is negative 3/5 times -1 minus pi squared. A negative times a negative is a positive, so plus 3/5 +1. So this is 3/5. That's another 3/5. I'll just move it. That's 6/5 minus pi squared. Okay, and if you got a decimal and did math 9, you would get the same exact thing. Okay, guys, you've got to practice a lot, especially with the notation. Now, I'm going to do all of these as well. So you're going to have all of my work in front of you. Make sure that your notation, meaning like the way that you're writing it, is exactly as I am writing it. Okay, you're going to do great. I'll talk to you later. Let me know if you need anything. Bye-bye.